Alright, so I went ahead and did all the methods in GBA.c and all the macros in GBA.h. So now I'm ready to do my game. And we're going to be making Pong today. First thing we're going to do is set this to mode 3 and aura with background to enable. And if you don't understand what's happening here, then don't worry about it. I don't really know what's happening either. So next thing is let's test out some of our helper methods that we made in the file. Set the pixel to 10th row in the 20th column to red. And to test out your code, just pull up a Docker container and navigate to where you download your home or gate and run make mgba. You should get this nice red pixel here that we made programmatically. And so instead of a pixel, let's do a rectangle now. 10th row, 20th column. And these first two specify the top left corner of a rectangle. Now let's make the width. Let's make it a pretty wide 50 width and then 20 height. Let's make that blue this time. Go back to code. Great, I have a nice rectangle. And now what we're going to do is the GBA, it's a little bit weak to be drawing the background every single frame. So what we're going to do is we're only going to draw our backgrounds, like basically our 38,000 pixel backgrounds. We're only going to do that on our state transitions. So I see our first state transition is this default state where we're taking in the start state. So I'm just going to fill it with, let's say, blue. That'll be my start background. Great, so our code. Yeah, a nice blue background. I think we're ready to enter our game loop now. So in our game loop, it's just a while true loop basically, and it has a nice switch statement, and it's supposed to act kind of like a finite state machine. So the first thing we're going to do in our game loop is we're going to call waitForVBlank at the very top, and this prevents a lot of our screen tearing. We don't have to worry about it too much anymore. And yeah, that's great. And so let's say in our start state, if the user presses button start, and we just have to pass in current buttons and previous buttons every time we use this macro. Let's change our state to play. And as we said, so every time we make a state transition, we're going to fill the background there. So let's make our play state background. I believe in Pong it's black, so let's make that black. Let's go back to our code. Right now we have our start state, start screen, and if we press enter, we should get our play screen. Perfect. Now, within our play state, we're probably going to want some struct to represent our player's rectangle. I'll just make a struct rect. I'll have a row, column representing the top left corner of the player. Have a width and a height. And before game loop, let's initialize our player here. So, struct rect player. So this just allocates some spots on the stack for our player struct. Right now it's garbage data though, so we have to set it to some default values. I'll set the row equal to, let's just say around near the middle of our screen, 80. Player.column, let's say closer to the left of the screen, so it's 20. Player.width, Pong it tends to be skinny, so I'll just do 8. And player.height equals, let's say, 25. And so now this is an important concept here. So what we're going to do in these states is we want to separate our rendering with our game logic. We don't want to intertangle our game logic and our rendering. We just want to do all of our game logic and then all of our rendering. So I'm going to make a little comment barrier here. Drawing below. We'll do all of our drawing right here at the bottom. And in this area, in the middle, is where we're going to do our game logic. So first thing is, let's draw our player. So our player is something we want to display on the screen, so we're going to write here, player.row, player.column, height, player.width actually. Yep. Player height, so I'm repeating the ordering. Have to make sure it's passing in the right order. Let's make the player blue. Back to the game loop. GBA. I press enter. Nice, we have a nice player there. And so now let's make the player movable. So if key down, button up. Here you have to pass current buttons all the time. And let's say player.row minus equals 1. And if the key down, button down, current buttons. Let's say player.row plus equals 1. Go back and clear that, and hopefully the player can start moving now. You can see our player is moving. It's kind of leaving a trail here. And that's because I told you guys that we can't redraw our background every frame. So how do we overcome this? Well, what we're going to do is we're actually just going to straight up undraw the player. And by undraw, I mean just straight up replace the player with the background before we do our game logic. So this is basically erasing above. I'll just call it erasing above. I'll call this a redrawing below. So I'm just going to set drawRect DMA, player.row, player.call, player.width, player.height, and then we'll go black because that's the color of the background. So you can see we erase the player, we recalculate where it should be, and then we draw it back. So hopefully this will fix the problem. Perfect, so I have a moving player. The next problem is it tends to go out of bounds. So now next thing is let's add some bounds checking. So I'm gonna basically do if player.row minus 1 is less than 0, player.row equals 0. We want to cap it at 0, else player.row minus equals 1. Something similar here. Now this one will be a little bit different. Plus 1 is greater than 160. And this is because player.row only considers the top left corner of the player, but it's not considering the fact that the player is taking up some volume, right? Some area in the screen. Here, player.row. I think it's height. This is the height of the screen minus player.height. Else player.row plus equals 1. Perfect. That's some bounds checking. Let's go back. Hopefully it works. Yep, looks like the player cannot reach the ends. Great. So now let's have a ball. Let's make a ball. I'm gonna make a new struct for that. Have an int row. Let's call. Have a size, and also have something called a velocity. Vel row, int vel call. So up here, I'm gonna make a new ball. Struct ball. Call b. B.row. Let's make it around the center. I believe that should be. I think it's around 80, and then b.call equals 120 if I'm correct. B.width. Let's make that, or B.size. Let's make that small. Let's make that 3. And how do we want it to travel? Let's say for now it's traveling towards away from the player. Let's try that. B.row vel row equals 1. B.call equals 1. So it's traveling basically that direction, top right, I believe. Actually, bottom right, because the rows are we're programmers, so row being positive means it's going down. So now what we're going to do is we're going to do this for our ball here. B.row, B.call. Both of them is going to be .size, and then it's going to be color. I think balls tend to be white. So. And also make sure to undraw to the top here. Draw, DMA, B.row, call, size. And we have to do black because that's the background. Hopefully, go into our code here. We should see a ball. Center. It's not moving, right? So we set up the rendering, we didn't set up the game logic for the ball. Let's go do that now. So, and I think we just simply do ball.x or ball.row plus equals ball.valRow. Ball.call plus equals, or it's not ball, b.row. B.valCall. See, hopefully that works. Nice, it's working. You can see it's kind of going off the screen now, and it's kind of bugging out. So what we're going to do is have to add some bounds checking as well. If b.row plus b.valRow, that's less than 0. B.row equals 0, and let's set, or actually I think the most elegant way is just flip the valRow. So that way we basically project it and see if it gets out of bounds, and so before we even move the ball, we just flip its velocity. And that if b.row plus b.valRow greater than 0, or plus b.size greater than, I believe it's height, or 160 becomes height. And I'm going to change these 160s to heights because reusability. So b.valRow times equals -1, so you can kind of see they're doing the same thing. So I could do an OR statement if I wanted, but so that should cover the at least the rows. So now we have to do some columns things. So b.call plus b.valCall less than 0, 1. B.call plus b.size call plus b.size greater than width. B.val -1. Oh, this should have been -1. Missing a semicolon somewhere. There it is. And let's see if that works. Hopefully that clears all the problems. Nice, bouncing. Perfect. Okay, so now we have to also notice that it's not actually colliding with the player yet. It goes right through it because we didn't implement the logic. So let's go do that next. In order to do this, I think we're going to need rectangle collision logic. And so I'm going to go find that online right now. Okay, so now what I'm going to do is, if there's any collision with a rectangle, if rect collision player or ball, and we'll do that before we do this incrementation. Let's flip the b.valCall again. Perfect, it's working. And it is leaking into the player a little bit. You can see it kind of enters the player struct a bit, but that's fine. Okay, so next thing I have to do is to kind of decide when our player wins. I just realized that if our ball ever hits the left side of the screen, then I think the player loses. So instead of doing this, let's make a state transition. State equals lose. And we'll fill it with a lose screen, whatever they call it, background. So it's probably going to be red. Let's do that. And we're also going to break. And now next thing is, if this happens, I actually think we just win. So our state equals win. So fill screen DMA green. We'll break. Hopefully that works. Go back. Great, we won. But it looks like there's no one defending it right now. So now let's make our enemy. So make a new enemy struct. Struct correct enemy. And player, let's set the enemy row to also be 80. Enemy.call. Height or width minus 20. Enemy.width 8. Enemy.height plus 25. And let's start drawing the enemy. So I'm going to do that. First, have to draw it over here. Sorry, enemy.row. Height. Let's make that red. And we'll also have to do something similar with undraw. We'll do black. Let's see if that works. Clear. Have a nice enemy there. Doesn't do anything. And so let's just make a greedy enemy AI. Let me think about how we can do that. So, okay. So I think the enemy center. Make an int enemy center height equals enemy dot should be the row, enemy dot row plus enemy dot height divided by 2, and like that. So if ball dot row is it's say greater than enemy center row, and enemy dot row we probably want to add 1. If e dot rows is below the center row, we want to go enemy dot row minus equals 1. Hopefully that AI works. This might be an impossible to beat Pong bot, but let's see. I can slow it down if I have to. Here. Ooh, we also have to subject it to the constraints of right here. So try this again. Let's do something similar here. Actually, that should be here for now. Okay. And then we like that should be up here. hopefully that works. Now let's just see. Might be a bug. I'll have to fix it. Perfect. Now all we have to do is just straight up which is also count from enemy now. And there's also a bug in the code that I realized. This was b.call. It was supposed to be b.row. Now that I fix that, should work. Okay, let's go. GBA. Nice. Great, we have a great game of Pong. The AI is probably impossible to beat right now. You know what? Let's try to make this game harder. You know what? This might be a little extra, but let's try it. So, with your VBlank counter, we kind of have a timer. So VBlank counter will increment once every frame, and there's 60 frames a second. So if VBlank counter mod 600 equals 0, you know it's been 10 seconds. Ball. Bell call positive. So this just increases the magnitude of it by 1. Got bell row 0. Our ball should be speeding up every 10 seconds. So hopefully it works. Oh my god, it got really hard. Alright, so one more thing is, I think the code requires you to be able to reset the game at any time. And I think the most clever way to do it is make a void initialize function. And everything that you need to initialize, make it a parameter, but specifically a pointer to that. We want to initialize a player, make our struct player p for pointer, and then struct. Oh, we should put that pointer there. I guess the asterisk conveys, I don't know, I'll just do player. I'm not really sure of C naming conventions. I'm more of a JavaScript person, to say the least. Ball p struct enemy, and we're just going to set player p. We can use this arrow notation like for row equals 80, and this is the same as doing dereference player p and then using a dot. So this is a very common this pattern of doing dereferencing and then doing dot is so common that C gave us an entire symbol to do it in a shorthand way. So I'm just going to copy paste all this. Place it player. Great, and then same thing with this ball. Great, and then this enemy. That real quick too. And yeah, so instead of doing all this initialization here, we will just initialize. We'll give a pointer to our player, pointer to our ball, pointer to our enemy. And I just want to verify our code still works. What we do is go thing. Does our game still work? Looks like it does. Great. So go back to VS Code. And now what we can do is we basically have to pull on all our states. So I'll even do it at the start state just to be consistent. Maybe you don't have to for your game. If key just press, I think it was a button that was a select that they wanted you to do. Alright, buttons, previous buttons. You just set the state equal to start, and then you call initialize on your basically the same code here. and then you break. I think I'll just copy paste some of the states. Nice. I wonder if I could get away with doing it below all of these cases. Actually wonder, I feel like I could get away with it. Maybe I'll do it in the top. Yeah, I'm gonna try that. I think that would work. We're in our game. If I press backspace, tell me it goes. Ah, something broke. Let's okay, maybe I was got too cocky. Why would this not work? Oh, because it's breaking us out of our while loop. I see. Maybe we can get rid of this break. Oh, I forgot. Of course, when we're changing our state, can you believe I forgot? Fill CMA with our blue. Basically the same transition here. Here, GBA. Now we press backspace, get our start. Perfect, see? So this is kind of like how you do it, make it restart your game. Now it's getting really hard. I already won. I press backspace to take start screen. Perfect, yeah. So I guess that's a clever way of just put it above your switch statement, so that way it's like a global interrupt, if you know what I mean. And good luck in the first GBA awards. So, as you all might know already, Professor Southern passed away. And despite that, I really think he would love to see y'all make the best game y'all possibly can. And I would really like to commemorate this first GBA awards in his honor. And I would love to see all the games y'all make, and I really can't wait to see the winner. But thank you guys so much. It's been a great course so far, and I'll make sure to make a video for Homework 9 as well. Thank y'all.